You've been looking into mirrors your whole life, and they've been lying to you. Every morning, you see your right hand turn into your left. You accept it. You never question it. But what if I told you the mirror isn't reversing left and right at all? What if the confusion isn't in the glass, but in your mind? Richard Feynman once looked at this simple question, a question a child could ask, and found something terrifyingly beautiful. Because the moment you understand what a mirror really does, you realize how easily your brain can fool you about reality itself. And once you see it, you can never unsee it. Most people grow up believing a simple sentence, mirrors reverse left and right. It sounds true, it feels true, and it seems so obvious that no one ever bothers to question it. But this is exactly the kind of statement Richard Feynman warned us about. A sentence that feels comfortable can quietly replace real understanding. When you slow down and actually observe what a mirror does, the entire idea begins to fall apart. A mirror performs only one physical action. It flips the direction that points toward the mirror and sends it back toward you. In other words, it reverses front and back. That's the only transformation happening. There is no special rule inside the mirror that knows what left is or what right is. The glass doesn't care about human labels. It simply reflects light straight back along the same path it came from. To see this clearly, imagine standing sideways in front of a mirror. If you raise the hand closer to the mirror, the reflection raises the hand closer to you. Nothing about left or right has changed. The relationship is purely about distance from the mirror. Near becomes far. Forward becomes backward. The physics is brutally simple. If mirrors really reversed left and right, something strange would happen. Your reflection would appear rotated in space. Your head would be on the side. Your feet would be misplaced. But none of that happens. Up remains up. Down remains down. The only axis that flips is the one perpendicular to the mirror's surface. Everything else stays exactly where it is. This is why Feynman loved this example. It looks confusing, but the moment you strip away the words, the confusion vanishes. Nature is not doing something complicated. We are. The mirror is innocent. It is doing exactly what the laws of reflection demand, with no extra tricks. A powerful way to feel this is to imagine an arrow pointing straight out of your chest toward the mirror. In the reflection, that arrow points straight back at you. That's the reversal. Now imagine arrows pointing left, right, up, or down. In the mirror, those arrows still point left, right, up, and down relative to the mirror's surface. Nothing magical happens to them. The reason this feels so unintuitive is that humans are deeply attached to the idea of faces and bodies. When we see a person in a mirror, our brain doesn't treat it like a simple optical process. Instead, it treats it like another person facing us. And a person facing us has their left and right swapped relative to ours. But that swap comes from rotation, not reflection. This is where the illusion sneaks in. We unconsciously imagine ourselves turning around to face ourselves. That imagined rotation flips left and right. Then we blame the mirror for something it never did. The physics stayed clean and simple the entire time. Feynman often said that the first principle of science is not to fool yourself, and that you are the easiest person to fool. The mirror example proves this perfectly. We are fooled not by complex equations, but by everyday language. The phrase left and right reversal becomes a mental shortcut that stops curiosity. Once you drop that phrase and focus only on what actually happens, the mystery dissolves. Light hits the mirror. Light bounces back. Depth is inverted. End of story. Everything else is interpretation layered on top by the human mind. This lesson matters far beyond mirrors. In science, students often memorize names, definitions, and slogans without truly understanding the underlying process. Feynman hated that. He believed that if you couldn't explain something in simple terms, you didn't really understand it. The mirror forces you to confront this uncomfortable truth. When you finally see that the mirror only reverses front and back, something clicks. You feel a small shock of clarity, not because you learned a new fact, but because you unlearned a false one. And that, Feynman would argue, is often the hardest part of learning. The mirror becomes more than a piece of glass. It becomes a quiet teacher, showing you that confusion doesn't always come from the world being strange. Sometimes it comes from the stories we tell ourselves about how the world works. The moment you realize that a mirror does not reverse left and right, a new question immediately appears. If the mirror only flips front and back, then why does it feel so strongly as if left and right are swapped? The answer, as Richard Feynman loved to point out, has nothing to do with glass or light. It has everything to do with how the human brain imagines space. When you look into a mirror, you don't just see shapes and colors. You see a person. Your mind instantly recognizes a face, a body, and an identity, and the brain does something automatic and unconscious. It compares that person to itself. But it doesn't compare by reflection. It compares by rotation. Imagine another person standing in front of you, facing the same direction as you. If that person turns around to face you, their left and right will now be opposite to yours. This swap feels completely natural, and we accept it without thinking. The crucial mistake is that your brain treats your reflection as if it has turned around to face you. But the reflection never turns. It doesn't rotate in space. It doesn't spin around its vertical axis. It simply appears because light bounced back toward your eyes. The brain adds the rotation afterward without asking your permission. This is the heart of the illusion. Your mind invents a transformation that never happened and then reacts to the consequences of that imagined transformation. Left and right only seem reversed because rotation always swaps them relative to the observer. You can feel this more clearly with a simple thought experiment. Imagine you're wearing a watch on your left wrist. In the mirror, the watch appears on the right side of the image. Your brain instantly thinks left became right, but what actually happened is simpler. The side of your body that was facing left in your frame of reference is now facing right relative to you, because you imagine the reflected person turned around. Try imagining a clone of yourself standing inside the mirror, facing the same direction as you. In that case, the watch would still be on the left wrist. No confusion. The illusion only appears when you imagine the clone turning around to face you. Feynman loved examples like this because they expose how deeply human thinking relies on mental shortcuts. We don't carefully analyze spatial transformations. We rely on familiar body-based reasoning. Faces, hands, and symmetry dominate our perception, even when they mislead us. Left and right are not built into the universe. They are relational concepts. They only make sense when you define a viewpoint and an orientation. Change the orientation, and left and right change with it. The mirror forces your brain to juggle two reference frames at once, and it quietly chooses the wrong one. This also explains why text appears reversed in a mirror. Letters are designed to be read from a particular facing direction. When their front-back orientation is flipped, your brain again imagines rotation instead of reflection. The result feels like a left-right reversal, even though it isn't. What makes this so powerful is that the illusion is nearly impossible to unsee at first. Even after understanding the physics, your intuition still whispers the old story. This gap between understanding and intuition is something Feynman talked about often. Knowing the explanation doesn't instantly rewire your instincts, and that's okay. Science is not about feeling comfortable. It's about being honest with reality even when your brain resists. The mirror teaches you that your perception is an active process, not a passive one. Your mind is constantly constructing a story about the world, and sometimes that story is wrong. This lesson extends far beyond mirrors. In science, people often trust what feels obvious instead of what is true. The mirror reminds us that obviousness is not a reliable guide. Our brains evolved to survive, not to perform precise geometric reasoning. Feynman believed that the joy of science comes from moments like this. Moments when a familiar experience suddenly reveals a hidden layer. You don't just learn a fact, you learn something about how you think. Once you truly grasp that your brain is responsible for the left-right illusion, the mirror becomes strangely humbling. It shows you that reality didn't trick you. You tricked yourself. And in that realization, there is both discomfort and beauty, because the moment you catch your own mind in the act of being wrong, you take one step closer to real understanding. Once you accept that the mirror is not reversing left and right, and that your brain is responsible for the illusion, a deeper idea begins to emerge. The confusion exists because we secretly believe that directions like left and right are fixed properties of the universe. But they are not. They only exist relative to a point of view. Change the perspective, and the meaning of those directions changes with it. Left and right make sense only when there is an observer with a defined orientation. If you turn around, your left and right swap instantly. Nothing in the world moved, yet the labels changed. This alone should tell us that left and right are not absolute features of reality. They are relationships. The mirror exposes this weakness in our thinking. It forces us to confront two perspectives at the same time, our own and the reflected one. The moment we do that, our intuition collapses. We try to hold on to fixed directions while the situation demands flexibility. Front and back feel different to us because our bodies are built that way. We have eyes on one side, not all around. We move forward more easily than backward. Because of this, front and back feel physically meaningful. Left and right, however, are defined mostly by symmetry. There is nothing in the laws of physics that marks one as special. This is why mirrors reverse front and back so cleanly. The mirror has a surface, and the direction perpendicular to that surface gets inverted. That's a geometric operation, not a psychological one. Everything else remains untouched. The mirror does not care how humans label directions. It only obeys geometry. But the human brain doesn't think in geometry first, it thinks in stories. It asks, who is that person in the mirror? And then tries to make sense of the scene using social and bodily intuition. This is where perspective takes over and logic quietly steps aside. Feynman loved pointing out that nature does not share our preferences. The universe does not know what left means until we define a reference frame. And the moment we change that frame, the meaning dissolves and reforms somewhere else. This idea becomes incredibly important in physics. In classical mechanics, motion depends on the frame of reference. A ball can be moving or standing still depending on who is watching. Neither description is more correct than the other. Both are true within their own perspective. The mirror is a simple doorway into this concept. You think something objective has happened, a reversal of left and right, but in reality, you are witnessing a clash between reference frames. Your brain wants one consistent story, but the situation refuses to provide it. This is why the mirror feels unsettling. It exposes the fact that our everyday understanding of space is fragile. We get by using shortcuts that work most of the time, but fail under careful inspection. Feynman believed that these moments of failure were gifts. They showed where thinking needed to become sharper. He often said that the goal of science was not certainty, but clarity. And clarity often begins by recognizing where intuition breaks. The mirror teaches us that perspective is not just a philosophical idea. It is a practical tool for understanding reality. Without perspective, directions have no meaning. Without reference frames, motion orientation and even identity become slippery. In modern physics, this lesson grows even deeper. In Einstein's relativity, time and space themselves depend on the observer. Events that seem simultaneous to one person are not simultaneous to another. Just like left and right in a mirror, these concepts feel absolute until you examine them closely. The mirror prepares your mind for this kind of thinking. It quietly tells you that reality is not organized around human convenience. It is organized around relationships, symmetries, and transformations. Once you internalize this, the mirror stops being confusing and starts being revealing. It becomes a small everyday experiment in perspective. A reminder that the universe does not owe us intuitive explanations. And this is why Feynman valued simple questions so deeply. They don't just teach facts, they reshape how you think. The mirror doesn't just show you your face. It shows you how easily the mind mistakes perspective for truth. Understanding that difference is one of the most important steps in learning how to think scientifically. Once you understand the mechanics of a mirror and how your brain creates the illusion of left-right reversal, you begin to see a deeper lesson. This simple, everyday phenomenon is not just about reflection. It is a window into the way humans learn, think, and sometimes fool themselves. Feynman loved using ordinary experiences like this to teach extraordinary lessons. He believed that real understanding begins when you stop taking explanations for granted and start asking why. Even about the simplest things, the mirror shows us that words can easily replace understanding. Saying mirrors reverse left and right is comfortable, it feels true, it passes as knowledge. Most people never go beyond that sentence. They accept it, repeat it, and move on. But comfort is not comprehension. Feynman's warning was clear the moment you let language substitute for thought. You stop learning. You may appear knowledgeable, but you have not actually grasped what is happening. Science, he argued, is built on curiosity and careful observation. It begins with questions that seem small or even silly. Why does a mirror flip left and right? Why does the sky appear blue? Why does ice float? Each of these questions is an opportunity to confront your assumptions and uncover hidden truths. The mirror is a perfect example because it is something so familiar that we never notice it. Yet it exposes deep patterns about perception and reality. When you look into a mirror and think left has become right, you are experiencing the consequences of your mind's assumptions. Your brain creates a narrative to make sense of the reflection. The reflection itself is entirely neutral. The laws of physics have done nothing complicated. All the complexity is in your interpretation. This teaches one of the most powerful lessons in learning. Real understanding is active, not passive. You cannot memorize your way to comprehension. You must engage, visualize, and question. Feynman emphasized that science is as much about learning to think as it is about knowing facts. The mirror's lesson extends far beyond optics. In any field, it is easy to accept explanations without testing them. We take statements at face value, repeat them, and assume we understand. But when we examine the processes behind the statements, how something works, why it behaves that way, and how our perception interacts with it, we uncover a richer, more accurate picture. The mirror also teaches humility. It reminds us that even our own perceptions can deceive us. What seems obvious may be entirely wrong. The brain has shortcuts designed for survival, not precision. These shortcuts work most of the time, but they fail when we apply them to careful observation. Feynman loved showing students that the ordinary world is full of illusions. Recognizing these illusions is the first step toward scientific insight. Moreover, the mirror demonstrates the importance of perspective. Science is often a matter of changing frames of reference and questioning assumptions. The human mind naturally prefers simplicity, yet the universe does not conform to simplicity. Mirrors, particles, forces, and even the fabric of space-time follow their own rules. Learning science is learning to see these rules clearly, without letting intuition or language get in the way. Finally, the mirror encourages patience and curiosity. Understanding it fully requires slow observation, imagination, and thought experiments, exactly the methods Feynman championed. There is no shortcut. The satisfaction comes not from memorizing a fact, but from seeing the world correctly. When you finally grasp what a mirror actually does, you experience a small thrill of clarity. You feel a deeper connection to reality. And you realize that the mirror is not just showing your reflection, it is showing the process of thinking itself. This is why Feynman valued questions like these. They are simple yet profound, mundane yet revealing. They teach us how to observe, how to reason, and how to question. The lesson of the mirror is universal. Never confuse names or words with understanding. Always test your assumptions and embrace the wonder of seeing the world clearly. It is a lesson that applies to mirrors, to physics, and to life itself.